Hello, manufacturing leaders, process engineers, and mad scientists everywhere. Welcome to Tools for the Trenches, where we make manufacturing experts. Today's topic is about sampling plans and data collection. What is a sample, and why do we even take samples? Well, a sample is a small portion of an entire population or an entire universe of something for the purpose of evaluation. So we could take samples of something and evaluate this sampled thing in order to better understand and better characterize the entire population of this thing, whatever this thing is. So I'm holding up a few pilot pens, and I could test these pens and see how long the ink's going to last. And that's going to give me some idea about how long the ink will last on all the pens that I could buy in the future. So these few pens are telling me a little bit about all the pens in the universe of pilot pens. This is a very important concept in statistics because it's expensive to evaluate something. And so if it's expensive to evaluate something, then the more samples you evaluate, the more expensive your data gets. If you evaluate a sample size of, say, 30 pieces, that 30-piece lot is a lot less expensive to evaluate than the entire population, because the entire population could be 10 million pieces or more. So a sample is just a small reflection of the entire population. And this concept of sampling means that you can take just a small quantity of the total population and then use the data that you derived from that small sample size to make inferences about the entire population. Let's look at a bluefin tuna as an example. Sushi grade tuna sells for between $40 a pound and $200 a pound. And a Japanese sushi restaurant once paid $3 million for a 612-pound bluefin tuna. In the case of tuna grading, you can really understand the high cost of pulling samples. So fish markets, they want to minimize their sampling, but still get enough information to correctly grade the fish. They can't afford to evaluate the entire fish, so they just pull out a small core sample and they grade that one small sample in order to characterize the quality of the entire fish. You see, sampling is a good reflection of the entire population. But it's also important to understand that the sample data is never 100% accurate. There's a small amount of unknown difference between your sample data and the actual population's data. And this is called standard error. And your goal is to develop a good sampling plan and to minimize this error so that your sample data reflects the entire population as closely as possible. Now, let's discuss a good sampling plan. First, you need to understand exactly what you want to measure. In the case of gathering your process data, you want to get random samples over the course of time, and these samples should represent normal process variation. And this includes different lots of raw material, different operators, maybe different room temperatures and humidity. But you don't want to collect samples from a process if there's an out of control situation. Let's say your operator is struggling because there's an unknown mechanical issue with the machine, and your operators are troubleshooting this problem. The machine's not in steady state, and the operators are making a lot of scrap. In this case, you want to wait for another day to collect your samples when the process is actually running well. So the first critical aspect of a good sampling plan is to know what you want to measure, how you want to measure it, and how to collect the samples in a way that will best represent the entire population. And once you've collected these samples, be careful that they don't get damaged or corrupted through handling. The samples need to reflect what your customers are going to see when they receive your product. Another important part of a sampling plan and data collection is the measurement resolution. And resolution is the fine-tuning of your data. Let's say your process is weighing 1-pound packages of fudge. In this case, you don't want to round to the nearest pound because your entire collection of data is going to measure exactly 1 pound if you round to a pound. So instead, you want to measure to 1/10 of a pound, or maybe even two decimal places deep to the 100th of a pound, because this is going to give your data much better resolution. And the rule of thumb with data measurement is to measure your samples using 1 decimal point more than what your specification calls for. The last aspect of a good sampling plan is your sample size. And for this, I'm going to refer to something called the central limit theorem. Let's take a look at this principle now. A main concept of the central limit theorem is that the closer your sample size gets to the total population size, the more accurate your data is going to be. The central limit theory highlights the fact that the less samples that you take, the more standard error, or in other words, the more difference there will be between your population data and your sample data. So the larger the sample size, the less error that you're going to have in your data. But remember, just like in the case of the tuna, data always comes at a cost. So you want to understand the cost of your data. More samples are definitely better, but if your data is expensive, then go with 30-piece samples. And you can see in the central limit theorem graph that the standard error starts to flatten out at 30-piece samples. So you can pick up a lot more accuracy going from 1 sample to 30 samples than you can going from 30 samples to a 300-piece sample. So the rule of thumb is to use a 30-piece sample as a minimum in your data collection. Now, I wanted to note too that as you can see, there are 3 curves on this chart, and that's because each curve represents a different population size. A larger population is represented by the red line, and a smaller total population is represented by the green line. And hopefully that makes sense to you. You're going to have less standard error if you sample 30 pieces out of a total of 100-piece population than you are if you sample 30 pieces out of a total population of 1 billion. Your sample size as a percentage of the total population is also going to drive accuracy of your data.